Let's look at another combination example. So example number 7 from the packet states that an ordinary deck of cards consists of 52 unique cards. So just, your standard deck of playing cards, ignoring the jokers, has 13 different card types, ace, king, queen, etc., and 4 of each suit. So 13 times 4 is 52. It then asks how many Texas Hold'em hands of 2 cards can be dealt and how many standard poker hands of 5 cards can be dealt. So these are different types of games where in Texas Hold'em a player starts with any 2 cards from the deck, and regular poker people are dealt 5 cards. And we want to know, well, how many different hands could I possibly have? What is my event space, or what's my sample space depending on the context. So, but basically, these are both combination questions, and it could be very easy to mix up these problems as permutation problems. And with probability, we'll talk about that later and get back to that idea that's very easy to mix up. But basically, let's do the math first, and then we'll come back and circle back to why it makes sense after. But you could figure these problems out without knowing that it's a combination, because that's something that um, is not known. But in this case, the important thing to note is that the order which I get the cards doesn't really matter. Like if I'm thinking about a 52 card deck, uh, basically there's 52 cards in that deck. And one of the things that's a kind of a common issue with understanding this is when you draw the first card, a lot of times you think, well, there's not really that card is what it is, right? There's not a number of options. But since the deck is assumed to be randomized and shuffled, the first card could have been any of the 52 cards. So when I'm taking the first card, it technically has a choice, but it could have been any of the 52 cards, assuming proper randomization. So my first choice, there's 52 options. My second choice, right, there's now 51 cards left in the deck. So as I'm drawing a card, it reduces the size of the deck down to 51. And so, you might think, well, shouldn't this be 52 times 51? Which is not wrong, but it's ignoring the fact that there's technically duplicate hands. Because, right, say for example, first I'm dealt the ace of spades. Then second, I'm dealt the king of diamonds. That's technically a different hand. That's the same hand as if I were to draw the king of diamonds first and the ace of spades second. Because even though it's a different order, the order doesn't matter in my poker hand, and that's why it's a combination, not a permutation. Now this would be equal to 52p2, which is not correct for this problem, but it should be 52c2. And another a thing you can remember about drawing cards from a deck is it's always a combination because the order doesn't matter. The order which I draw cards does not matter. But anyways, again, to remember that formula, it's always n factorial divided by r factorial, and that's multiplied by the difference of them factorial as well. And another simple trick that you can do is remember that factorials will cancel with each other down to the point where the difference between them will be left. So technically it doesn't cancel exactly like that. But one trick that you could write is if you cancel this factorial, you could cancel it with the exclamation point. It would just leave all the numbers in between 52 and 50. Skipping down to 50, and that's all divided by 2. So there's mathematical tricks for simplifying this, but just kind of imagining what this chain looks like, right? 52, 51, 50, 49, etc. 50, 49, etc. So the 50 will cancel with all of the 50s, but it will leave me with the first 2 numbers. Now, this is just sort of in my imagination what will happen, but that would be equal to 26 times 51 by simplification, or again, I could just use a calculator to do all this math for me. And as like with permutations, combinations, your calculator has that option as NCR. You need to type in the first number in front. 52 NCR 2. And that will give us that number. Or, that's equal to 26 times 51, which is 1326. But again, what I wanted you to notice is that really you could still figure this out from common sense. It's easier to use the formula, but it's harder to know which formula to use. So I'm trying to give you the tools so that you can figure it out without necessarily relying on other examples. But notice that with the permutation problem, it's the same math, 52 times 51. It just cut in half because as the example I posited, well, the possibility of drawing ace of spades then king of diamonds, there's technically 52 times 51 unique orders of the arrangements, but since there's only two cards drawn, there would be kind of only two ways I could be dealt that hand. I could do ace spades, king diamonds first, second, or king diamonds, ace of spades first. So really, this just gives me double the options. I should cut it in half to get the truly proper amount of hands that are ace of spades, king of diamonds. And basically, this would be the number of unique starting hands I could have, which is quite a lot. So it makes the game a little bit more interesting. And now if you cut suits out of the picture and other things, there's other math that goes into various different situations. And the way that people get very good at poker and poker odds is by kind of understanding the base cases. And really, usually they just memorize probabilities of certain events. But you can know some of the basic numbers of probability can help you to calculate other things. But most of the players who are really, really good at poker don't actually really do math as they're playing. They just kind of know what it is by experience. And obviously they study it as well. But anyways, or let's say we're talking about standard poker hands where we're draw 5 cards, say ace of spades, king of diamonds, queen of hearts, 10 of clubs, and then a 2 of diamonds or whatever. Any type of unique hand. This would be given by 52 choose 5. Again, basically we start with the first number factorial divided by the bottom number factorial times the difference between them factorial, which would be 47. And that will give us our setup. Or since, again, this math would technically simplify to be 52 all the way down to 48. And notice that on top, that's NPR. And on bottom, I'm dividing by the number of overlapping unique hands, which is N minus RPR. Sorry, no, it's just N minus R factorial. Or sorry, R factorial, whatever. My point stands. I said it wrong, but basically it would be all of this. It's quite a terrible answer, and again, I would just probably recommend using a calculator to do that. But ultimately, I want you to kind of understand the math behind what's going on, which if you just use your calculator, it's kind of taking away the understanding and the concept. So you don't want to be overly reliant on your calculator because you want to understand what's actually happening with the math that you're doing. Because learning math without really getting it is not really that helpful. Anyways, there would be 2.6-ish million starting 5-card hands in regular poker as well.